Hey everyone, welcome back to my channel. Today we're gonna work on a question called minimum difficulty of a job schedule. It's labeled as a hard question, and the question states you want to schedule a list of jobs in D days. Jobs are dependent, and to work on the I job, you have to finish all the jobs before I, and you have to finish at least one task every day. The difficulty of a job schedule is the sum of difficulties of each day of the D days. And the difficulty of a day is the maximum difficulty of a job done in that day. So you're given an integer array job difficulty and an integer D. The difficulty of the ith job is job difficulty I. Return the minimum difficulty of a job schedule, and if you cannot find a schedule for the jobs, return -1. Looking at example 1, we can see that job difficulty array has 6, 5, 4, 3, 2, 1, and then the days allowed to split them is 2. So in order to have a minimum difficulty of a job schedule, we would put 6 to 2 here. We want to minimize it because the job difficulty for each day is the max number in it. So it would be 6 plus 1. That would give us the min difficulty, which is 7. For example, if we choose to put 6, 5, 4, 3 here and we move the 2 to day 2, then it would be 6 plus 2, right? And then that would make the minimum job, the job difficulty 8, which is no longer the minimum. And as you can see, this is a DP question, and we can start writing this question. So here it says you have to finish at least one task every day. So we want to check if length of job difficulty is smaller than D, then we return -1. So this means that if, for example, if we have like 6 jobs, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 6 jobs, and then we have to divide it among 7 days, but the requirement is to have at least one job every day, then there's no way to divide them, right? So we have to return -1. And I'm gonna define a list called max jobs remaining, and I'm gonna copy the job difficulty, initialize it as the job difficulty list so that it's easier for it to be assigned. And then let's go through the job difficulty list. For I in range length of job difficulty -2, -1, -1. So what does this mean? This means basically we want to go backwards from the job difficulty. The second last, we start at the second last. The reason for that is max job remaining, if it's the last one, it's always the max job that's left is always going to be itself, right? And then we start at the second last and we compare it to the next one. And then if it's bigger, then we keep itself in our max job remaining. If it's smaller, then we assign it to the bigger one that's remaining, right? And we keep going until we reach the end. But for this example specifically, since this is all descending, we'll just max job remaining will just always be itself. But for example, if we have a list, job difficulty list looking like 3, 4, 5, 1, then our max job remaining would look like, let's say we assign it to itself first. So in the beginning, it will be like 3, 4, 5, 1, and then let me write the code also. Max jobs remaining I equals max of max jobs remaining I or job max jobs remaining I plus 1. So we want to see if 5 or 1 is the bigger one. We start at 5, right? The second to last one. And then since 5 is the bigger one, you keep 5. And then here we go into 4 and we compare 4 to the next one, which is 5, and 5 is bigger, so we replace that to 5. And then we look at 3 to 5, and 5 is bigger, so we replace that 3 to 5. And this is gonna be our match job remaining after we go through this. Okay, so then I'm gonna start writing my DP. I'm gonna use the Python decorator cache for memorization, and I'm gonna define my DP with I and days remaining. So I and days remaining will be our DP states. I is going to be like the first task for the day, like for today. And D, days remaining, is gonna be how many days are left. So those are our two states going into the DP. And then starting in the DP, we want to check if the base case, right, if days remaining equals 1. If we only have 1 day left, then we have to automatically return whatever's left, right? That would be our base case. So we would return match jobs remaining I. And then I'm gonna make some DP variables. The result will be the minimum difficulty of a job schedule. Since we're looking for the minimum, we're gonna initialize it as the float infinity, like the biggest positive number, so we can replace it later on whenever we find a min or result that's more smaller than itself. Same as another variable, I'm gonna declare as daily match job, and then I'm gonna declare it as 0. Yeah, so now I can I'm gonna write another for loop that's gonna do the DP recurrence thing. So I'm going to iterate through possible starting index for the next day and ensure that we have at least 1 job for each remaining day. And how we can do that is, like, for example, if we only have 2 days and we have 6 variables, so on the first day it's possible to just pick 6, or you can pick 6, 5, or 6, 5, 4, but we can pick 6 up to 2 because we have to keep 1 extra for day 2, right? So let me write it first. For j in range I, because we want to start at the first task of the day, to j, to the length of job difficulty minus days remaining plus 1, because let's say like we start we want to go from index 0 here to what's j? The j would be to 2, right? So the length of the job difficulty would be 6 minus days remaining would be 2. So it's like index 4, right? 0, 1, 2, 3, 4. But because the second variable is not included in range, that's why we have to plus 1. So daily match job will equal the match between daily match job or job difficulty j. And then result will be, this is where our DP recurrence will happen. Result will equal the min between result or daily match job plus DP j plus 1 and days remaining minus 1. And in the end, we just return the result. And we call our DP by doing return DP. We start at index 0 and then we give them the t variable, which is like the days from the very beginning. Closing parenthesis does not match opening parenthesis. Max drops remaining I equals max between max drops remaining I and max drops remaining. Oh, sorry. It's yeah, so this is how I would solve this question. Let me know if you have any questions, and thank you so much for watching.